This is the second day of review of Chapter 5, Sections 1 and 2, Solving Systems by Graphing and Substitution. So let's take a look at our first problem here. And they're asking us to solve the system by graphing. So first step I'm going to do is get y by itself. I'd like to use the slope-intercept form to graph, and that's what I'm going to go ahead and do. So I subtracted the 1/2 x from both sides. And so what that did is it canceled out the x term on the left-hand side, leaving me just with y equals negative 1/2 x minus 6. So from that point, I'll go ahead and graph that line. Now, I've only got 5 spaces going down, so I'm going to go ahead and count by 2's. So I'll tell the reader that by just putting marks in here showing that they're going by 2's, and I'll do the same thing for the y-axis as well. And then I'll go ahead and plot that down 6 spaces. So this is 2, 4, 6. And then I can use the slope of negative 1 to 2. So I'm going down 1 over 2 to the right. And so even though I'm counting by 2's, this is like 2, 4, or so this is like 2 and then 2, 4. So this is 2 over 4, which is the same as 1 to 2. So it's a negative slope, so I need to go downhill from left to right. So I'll do that a couple more times. And so now I've got some points on that line, so I can go ahead and draw it between those points. And taking a look at our next line, we've got 6x plus 2y equals 8. So I'm going to go ahead and subtract the 6x from both sides, and so that leaves me with a 2y equals negative 6x plus 8. So I need to divide by that coefficient of 2, all numbers by 2, and that leaves me with y equals negative 3x plus 4. So I'm going to start with the positive 4 up 4 spaces there, and then use the slope. The slope is, again, another negative slope, down 3 over 1 to the right. So down 1, 2, 3, and then 1 to the right. And so again, that's like going 6 down, because it's 2, 4, 6 over 2. So 6 over 2 is the same as 3 over 1. So that's how that works. So I'll continue. 1, 2, 3 over 1, and look, that's where they cross right at this point. So I'll go ahead and draw the line so you can see what's going on here. And we've got the 2 lines, and you can see how they cross right at this value. And so what is that number? Well, it's 4 spaces right, and 2, 4, 6, 8 spaces down. So 4 comma negative 8. That's where the 2 lines cross. So this is a good method to at least see what the answer represents, which is a point where the 2 lines cross, or a point that is shared by the 2 lines. However, there are other methods which are a little bit easier and take a little less time, and if the number was really big or a fraction, it'd be difficult to read off of a graph. So let's come up with another method, and that is substitution. So this first problem worked real well with substitution because y equals 2 expressions. So let's go ahead, and since y is x minus 4, let's put that in place of the y down below. So I've got x minus 4 equals 4x minus 10. So I'll go ahead and solve this by moving x's to one side, constants to the other side. And this is what we've got now. 6 equals 3x. I'll divide by 3, and I've got 2 equals x. So I'll take that 2, put it back in for one of these x's here. Y equals 2 minus 4. So y is negative 2. Let's check that answer, make sure it's right. This is where the 2 lines will cross. So to verify, I just put in the other equation that I did not substitute into to find out what y is. So let's see if it works. So it's this equation here, y equals 4x minus 10. And put the negative 2 in for y. I'll put the positive 2 in for x, and see if I do get negative 2. Negative 2 equals 8 minus 10. Yes, sure enough, negative 2 is negative 2. So when you get an identity like that, you know you are correct. Well, another substitution problem that's a little bit tougher is when we don't have the variable solved for. So we can still do it, though. We're going to substitute y equals 1/2 x minus 1. So 1/2 x minus 1 is what y is. We'll put in that other equation. So 4x minus 2, but in place of y, you put that expression, 1/2 x minus 1. You set that equal to 14. So I'll distribute, and I've got 4x minus 1x, because half of 2 is 1, and then a plus 2 right there, and this all equals 14. So I'll go ahead and do a little more work here. These two numbers make 3x plus 2 equals 14, so I need to subtract that 2 from both sides, and that'll leave me with 3x is 12. And so when I go ahead and divide by 3, I'll end up with x, show that division there, and x is 4. So we'll take that 4 and put it back in for one of these x's. put it in that bottom equation. Y equals 1/2 of, and then 4, x in this case is 4, minus 1. So half of 4 is 2, 2 minus 1 is 1. So y should be 1. So let's check and see if 4, 1 is the correct solution by putting it back in that top equation. So my check is this: 4 times by x, which is 4, minus 2 times by 1 should be 14. Let's see if it works. So 4 and 4 multiply to make 16. 2 times 1 is 2. And yes, 16 minus 2 is 14. So when the two numbers make an identity, then we know we are correct. Well, taking a look at the last type of problem, there's some word problems here. So a drama club earns $1,040 from a production that sells a total of 64 adult tickets and 132 student tickets. And so it says an adult ticket costs twice as much. So cost. So this is like adult ticket equals twice as much as a student ticket. So it'd be like 2s. So A would end up representing my cost of an adult ticket, the way I set up that equation right there. And then I have S equals the cost of a student ticket. And from there I'll be able to come up with my other equation. So once I see that they're comparing the two, I try to write an equation to match that, and I look further and I look for what the question is, and they're asking me to write a system of equations, and they want us to find the cost of each ticket. So adult, A is the price of the adult ticket, S, the price of the student ticket. So my first equation goes this way. It's a value equation. They give us a value right here of $1,040. So we know we bought 64 adult tickets, or we sold 64 adult tickets, and we sold 132 student tickets. So if I multiply the number of tickets by the cost of the ticket, and then add those together, I should get that $1,040. And so my other equation is just A equals 2S. So it's a great substitution problem. I'm going to take that 2S, put it in place of this A right there. So 64 times by 2S, and plus 132S equals 1,040. So I'll multiply. Doubling 64 gives me 128S plus 132 equals, and that's an S right there as well, 1,040. So adding these two numbers together gives me 260, it looks like, 260s, and this all equals 1,040. So I'll go ahead and do that division, and I see right away the zeros cancel out. So really all I'm doing is 26 into 104. And so S is going to end up equaling, in this case, $4. So 4 times 26 makes that 104. So now we know the cost of a student ticket. To find the cost of an adult ticket, you just double that, because that's what it says. Adult tickets double the cost, or twice the cost of a student ticket. So $8 for the adult ticket. So adult ticket equals $8, and the student ticket is $4. So look at the next one. It says you sell lemonade for $2 a cup and orange juice for $3 a cup. So now we know the cost. It's different than this problem, because here we were looking for the cost of each of those tickets. Now we know the cost of lemonade, know the cost of orange juice. It says you sell a total of 100 cups for $240. Supposed to write and solve a system, find the number of cups of lemonade and the number of cups of orange juice you sold. So we need to define some variables. We'll use L as the number of cups of lemonade, and we'll go with J as the number of cups. Oops, let's erase that. Cups of OJ. And so we'll set it up this way. L plus J, I'll use a lowercase j in this case here, equals, so let me go ahead and fix my J here to make it match. So L plus J is, there was 100 cups sold. So the number of cups of lemonade and the number of cups of orange juice made 100 cups. That's what we sold. Now the next equation is the value equation. We sold lemonade for $2 a cup, so $2 times the number of cups of lemonade, $3 a cup for orange juice, $3 times the number of cups of orange juice. And we made $240. So we can go ahead and solve by just moving one of the variables to the other side. So I'll go ahead and subtract the j from both sides, and I'm left with L equals 100 minus j, or negative j plus 100. And I'm going to substitute that in for L into this other equation. So my new equation is 2 times 100 minus j plus 3j equals 240. So I'll distribute, and I've got 200 minus 2j plus 3j is 240. So I'm subtracting that 200 from both sides, and that leaves me with the 1j equals 40. So orange juice, sold 40 cups of orange juice. Let's find the number of cups of lemonade. We can use this equation that we modified. So 100 minus 40, 40 from the total gives us 60. So 60 cups of lemonade. So we had lemonade, which is number of cups of lemonade was, and then we had 60 cups right there. And the number of cups of orange juice was 40 cups. So those are our answers. That's how we're going to do the problems on tonight's homework. Good luck.